Hello everyone. I've been trying to record this for like the third time now. I was doing glycolysis, including the structures. I thought it would be a good idea to personally do it, as opposed to you guys watching some other video. But that's fine too. Anyway, I'm going to get started. I can figure out. All right, good. So we have glucose, 6 carbon. 1, 2, 3. Okay, 6 carbon aldose. Here's our basic structure. And here we have our intermediate carbon, which dictates whether it's an aldehyde or a ketone. Alright, glucose. Make sure you can see it. Our first reaction involves hexokinase, which is irreversible reaction, or also glucokinase. And we utilize ATP for the first time. Investment of ATP, producing ADP. So we get our phosphate group. And that is given to this hydroxyl group here. Okay, so recall that our phosphate, when it's bound, is right. So it binds by way of the oxygen. See it? Okay. Just gonna write that as such. Everything else stays exactly the same. So it's pretty easy. Okay, and we call this glucose 6-phosphate. Okay, now our next reaction, which is reversible. It is reversible. Nothing else necessary. We will use an isomerase called phosphoglucoisomerase. There's different ways you might see this, but ultimately this is it. It's just phosphohexose isomerase. Same thing. And we're going to produce fructose. Oh man, no space. It's the same except for this. These two. The first two carbons, they change. So here we remove our carbonyl to the second carbon, which makes it a ketone. Here we form hydroxyl group there and H2. Everything else stays exactly the same. Sorry, I'm going to move it. Alright, H2. Alright, let's move that here to the middle. Next reaction, we have phosphofructokinase 1, and we use ATP. So this donates a phosphate group. This is not reversible. We produce, this is fructose 6-phosphate. Here we produce sorry, this is kind of ghetto, but it will be just fine. And also recall that fructose is a ketose, right? Glucose, aldose, fructose, ketose. Everything else is exactly the same. Okay, and then we have fructose 1,6-bisphosphate. Hope you can read backwards. Next reaction. So we split this right down the middle. Just along. Yes. In which we have a reversible reaction involving what's called aldolase. So this is aldolase, which cleaves this into 2 trioses. In the middle here we have something else, right? So 2 3-carbon molecules, one of which is, I'll explain it to you in a second. All you're gonna do is, it's almost a direct, it's almost exactly the same, but it is slightly different. Okay, same keep our phosphates, same here. Oops, no. Lastly, we develop, what we do is form a bond or 2 extra bonds. So we have a hydrogen here, extra hydrogen, so H2. Here, we have now formed nope, whoop, careful. We form a carbonyl group, right? 1, 2, 3, and thus we have now formed an aldehyde. So this is glyceraldehyde. Everything else is exactly the same. Okay, so this is glycerol. Make sure it's still on. Yep. Glycerol aldehyde 3-phosphate. And this is a ketone, so it's dihydroxy acetone phosphate, DHAP. Now this enzyme here, which can convert these 2 interchangeably, is triose phosphate isomerase. Again, this isomerase, all it does is convert a ketose to an aldose to a ketose back and forth. However, for this reaction, we will just use G3P, in which our next reaction, it is reversible. It's also a very interesting reaction because we're going to use an inorganic phosphate, which goes directly into the structure, and also we must have an oxidizing agent, which is, sorry, it's written funky here. Damn it. I'll redo it here. Let's redo it. I'll do it on this page here. Okay. We're going to move this structure here. Alright. I'm going to separate this into 2 videos. So this is G3P, just going to write G3P. Alright, now in this reaction we use, I'm going to go up like this, just because I can. We'll use inorganic phosphate, PI, And nicotinamide adenine nucleotide, which is NAD plus, which is an oxidizing reagent, so it'll remove electrons. And reduce itself to become NADHH plus. Oops. Alright. Now as a result, we have now produced excuse me. So this is our key thing here. Reproduce. Not sure it's still on. Okay. Not only, so we're going to keep our carbonyl group. This is because we have a full transfer of a phosphate group, which is PO4. So we're going to bind this carbon with its own, so you can do it like that, phosphate group. But this phosphate group really looks like this. Maybe I shouldn't. It's like this. So this is the carbon. We have oxygen, which is bound to phosphorus. And these all have a negative charge except for that one. That's how it really looks. So keep that in mind. Hope you can see that. Okay, I think you can. Yep. Alright. So we're good to go. Right. Alright, redo this to make it look. Okay. Keep that in mind. Alright, our next reaction. So we now have 1,3-bis phosphoglycerate. And these names are so, they tell you exactly what's going on, what it is. You have we have a phosphate on the first carbon and also the third carbon from glycerol bound with a phosphate group, or phosphated glycerol, which has an aldehyde-like structure. Okay? So our next reaction, we will use a kinase and we produce ATP. So this is a reversible reaction. Oh, I'm sorry. The enzyme here is called G3 or glyceraldehyde 3-phosphate dehydrogenase. Whenever you have NADH, it's going to have a dehydrogenase, no doubt about it. Next, we have our kinase. So this is called phosphoglycerate kinase. Kinases, they add phosphate groups to something, and here it will be, typically it's going to be a substrate, or to produce a product that's phosphated. Here it will be ATP, so we're phosphorylating ADP. So ADP producing ATP. And yeah, okay. And our result, we get, make sure you can see it. And this is going to come from the first carbon, okay? But look what happens. We'll keep, we'll keep our carbonyl group. But we'll also keep our oxygen, because this adenosine diphosphate, it binds with phosphorus by way of its own oxygen. Okay, so we have PO3. So we're going to keep this So we form a carboxyl group, carboxylic acid group. And this is called 3-phosphoglycerate. Okay, let's go to the next page. Or actually, save some trees, right? Let's go to the bottom. Gonna be happy little Californian tree savers. I'm going to the bottom of the page. And we're gonna convert this to pretty easy. This is a mutated or mutase reaction in which it is reversible as well. I'll just make it here. This is called phosphoglycerate, just abbreviate it, mutase. We also see a phosphoglycerol mutase. We move that phosphate group from the third carbon, make sure it's still on. Yep. Let's just go ahead and do this like this. And oops. So in this second carbon, we're going to move it to. So from here, all right. Dang it. All right. So get there, and carbon, hydrogen, and then here we reform and we are done. So here we have formed 2-phosphoglycerate. Great. Now, next reaction, which is also reversible, we will use a hydratase known as enolase, strip it of its, well, we'll form water with it, H2O. We'll form PEP. Okay, so we're forming phosphoenolpyruvate, enol pyruvate. Now the question is, where do we get these hydrogens, these two, and then the oxygen? Pretty easy. You get it from here, this hydroxyl group, and also from this hydrogen here. Okay. Let's restart that. We do this negative by forming a double bond between these two carbons. And all you do is, see, look at this, CH2, you just keep it the same way. So 1, 2, 3, 4 carbons. We lost this hydroxyl group, which is bound with this hydrogen to produce H2O. Done. And that's PEP. Let's go to the next page. So I'm going to take all of this. We'll start up here. So we have now we will form, using a irreversible reaction, ADP, we form ATP. Okay, how do we form it? Well, we're going to form it with this phosphate group. So we're going to remove phosphate, whoops, and form ATP, as well as our last substrate, or second to last, or really our last substrate. depending on the conditions. Actually, no, this is the end product no matter what. All right. Oops. All right. Now we're gonna form and keep our 4 bonds. So double bond is lost. Keep. And we also form here a double bond. So it's a ketone-based compound. 1, 2, 3, 4. Everything else stays the same. Just make sure stuff. Okay. Great. Thus we have now formed pyruvate. Let's now go ahead and do this reversible reaction. Now under anaerobic conditions, lacking oxygen, so we will form lactate, lactic acid. We use a dehydrogenase for this. This dehydrogenase is NADH plus. In the enzyme lactate dehydrogenase. I'm sorry, I forgot this previous one. It's pyruvate kinase. Again, whenever you say kinase, something's being phosphorylated. Some phosphate is being added. Alright, so we're almost done. CH3. Here we form Johnson group. Everything else stays the same. Boom, done. There you have it, folks. Easy peasy. Yep, and relatively easy. We're done with glycolysis. So good luck and Godspeed. Enjoy your weekend.